2x plus 2 in brackets times dx. Remember du over dx, but dx we bring it over. We then are going to divide by 2x both 2x plus 2 both sides. Just you're basically solving for dx. And again, I'm doing it how you might have seen your professor do it. Okay. I don't post anywhere these, no. So I would recommend that you try it with me or do a screenshot if you need to. Okay. There was those two questions before we did. Now 2x plus 2, if I replace the dx, so I'm going to leave the 2 for now, the 2 here. And this 2 could be actually inside or outside the integral. X plus 1 e to the u, and for dx, that's where we put du over 2x plus 2. Now, it doesn't seem like it's the same thing to cancel out, but technically this 2x plus 2 is 2 times x plus 1. So this 2x plus 2 and the 2 with the x plus 1 cancel out. And that leaves us with e to the u du, and exponential function
water in gallons per minute. Let's say if we have the differential equation f prime of x is equal to 3x, and also we're given the initial condition that f of 0 is equal to 7. With this information, find a particular solution to this differential equation. So how can we solve that? That differential equation. Well, that anthem of 3 is we need 7. So I'm going to replace this with, so I could say that is equal to c. So now I can rewrite the function, replacing this with c. So I could say that f of x is equal to 3 over 2 x squared plus c. And this is the answer I'm looking for. So that is the particular solution to this differential equation. Now let's go ahead and work on another example. Let's say that f prime of x
fucking pages. Okay.
is equal to 6x squared minus 5. And we're given the initial condition that f of 1 is 4. Go ahead and solve water in gallons per minute. What is the rate at t equals 12 minutes? Now to find the rate, we could simply just plug it in. We need to find v prime of 12. So all we got to do is replace t with 12. So it's going to be 100 0.05 times 12 squared. So I'm going to do this one step at a time. 9, 12, 8 minutes. Actually, not liters, but gallons per minute. So that's all you have to do for part A. Now what about part B? The f this, or the rate to represents the rate of change of f. Integration of f prime of t, which represents the rate of change of f.
Is it x? T. Very good. dt tells you, right? We won't put plus c in this case because it's evaluated. Then this is 36 t squared divided by 2. And then you show evaluating from 4 to 10 and so on. No worries. It's all good. I prefer if you people, respond. Doesn't matter if it's correct or incorrect. You're trying. So question number 8. Calculate the area between curves. Do you know how to do this one? First thing you want to do is plot it on the xy plane, find points of intersection, because area is the integral. You need to integrate, but it might help to know, first of all, like where are they intersecting, which one is above, which one's below, so you're subtracting properly. Okay, so if I draw this, you can for points of intersection you can equate them, yes. So for points of intersection, you equate them. So 3 minus x squared equals 2x. You know, people sometimes prefer not to do the graphing, but I just like want to encourage you to not be afraid of graphing. I'm just gonna put everything on one side so that we get 0 on one side once we're solving. And this one looks like we may need to factor.
With respect to time, this is simply equal to f of b minus f of a. So if we integrate the volume flow rate, or the rate of change of volume with respect to time, if we integrate that function from 0 to 30, it's going to give us the number of gallons of water that's going to flow out of the tank in the first 30 minutes. It's basically going to give us the net change of the gallons of water that's going to leave the tank. So we need to integrate from 0 to 30 v prime of t. And this is going to be equal to v of 30 minus v of 0. So v prime of t is 100 plus 2.43 t minus 0.05 t squared. The antiderivative of 100 is 100t, and the antiderivative of t to the first power is going to be evaluated from 0 to. So let's times 30, or 3 to 1.0, 3. It's a 30. Now, 3 response t is, so that's how many gallons is going to flow into the tank, or I mean out of the tank, in the first 30 minutes. Here's another problem that we could try. Try. In the first 30 minutes. That is one is and that's you going to 11 time. 0.25 zoom in watts of power. And one focus on 24-hour period. Function peep. So let's go ahead and use and we're going to how much energy is consumed in a typical 24-hour period? Energy is power multiplied by time. So let's say if you have a function for power, energy is going to be the integration of p prime of t dt. Now, if you want to find the net change, or how much energy is consumed, you can use this formula. It's p prime of t dt evaluated from a to b. And this is going to equal E of b minus E of a. So let's say if you have a function for power, energy is going to be the integral 24-hour period. Energy is power multiplied by time. So let's say if you have a function for power, energy is going to be the integration of p prime of t dt. Now, if you want to find the net change, or how much energy is consumed, you can use this formula. It's p prime of t dt evaluated from a to b. And this is going to equal E of b minus E of a. which will give us the amount of energy consumed in a typical 24-hour period. Period. So let's go ahead. 13.2 to 20 plus point divided by the answer is 300.
That in. Use the formulas. Like they actually give these are given on the formula sheet. They provide them to you. You'll end up needing to use them. So delta x is the same as when you use midpoint rule and left endpoints and right endpoints. The only thing it's in this case, you don't know what n is. It's a variable. It's just going to go to infinity. So you're going to keep it in terms of n. A and B you get from your bounds. So here it's 5 and 2. So you go 5 minus 2 over n, which is 3 over n. Xi, think about you start with A, moving on each time delta x. And this would be x1. This is x2. You keep moving delta x. So you start with A, you add delta x, and whatever, how many times you add delta x, that's your I. So you multiply by I. Delta x times I. Like how many times you have to add delta x. If it's x2, you add it twice. If it's x3, you add it 3 times, and so on. So if I wanted to find f at xi, and this is f xi star if you like prefer to say that, I might just not, I'll drop the star. I don't think I need to. So in this case, let's actually figure out what that is. For us, it's 2 plus, we already found delta x, so it's 3 over ni. So if I need to find f at xi, I have my function is what's in the integral, x squared minus 2x. So I'm going to put x squared, but instead of x, I'm going to put my xi. wants me to take a break. We'll finish this. We'll take a break after this question and resume. We have this until 4 o'clock. Now, you would want to expand this as much as possible. Just when you put it back in, it's just a little bit easier to do the limit afterwards and use summation. So if I expand the bracket like that, 2 plus 3i over n, when it's squared, remember you actually need to multiply the two brackets together. So you do FOIL, first, outer, inner, last. So that's going to be 4. Outer and inner give you 6 plus 6. That's 12 I over n. And the last terms is 9 I squared over n squared. Then I have minus 4 and minus 6 over ni. Now you can even simplify this a little bit more because you have this is like terms, and 4 and negative 4 you can cancel out. So that looks like we get 6i over n from just those two. So let me put that back into the limit now that some of you might do it all inside the limit notation, but for me, I find it's a lot of copying over and over stuff. So I prefer to do it on the side, some of this. So now that I found what fxi is, it's 6i over n plus 9i squared over n squared in brackets, because I still need to multiply it by delta x. That's 3 over n. Now, this 3 over n is not dependent on I. So you can pull it outside, but don't pull it outside of the limit notation, just outside of the sigma summation. Okay, so that's the first step I would do to just make it a little bit easier for us. 3 over n. It's like taking out a constant outside of the integral, same idea. So another thing you can do is also you can split this into two summation notations. So you can say 6ni plus another summation and say it's 9i squared over n squared. And again, you can also pull out this outside and this, but without I. Don't pull I outside. Okay? So we're going to have limit as n goes to infinity, 3 over n, 6 over n gets pulled out. And this is just I left, plus 9 over n squared gets pulled out, and this is just I squared. And now I can use the formulas I have. Okay, so look, this one we're going to use for this part, and this one for this one. Right, so let's go ahead and do that. So everything in the end is going to be in terms of n, and you're going to evaluate the limit. It is tedious. Like, it's very easy to make a mistake when you're doing this. So some things I wouldn't rush it to make sure. So like you want to make sure you have enough time, but. And so this is the limit you're going to do. You can simplify a few things like this n cancels this n. You can also cancel this 2, make this a 3. We can make this a 2 and this is a 3. This n cancels this one of these. I'm just going to bring it over here. So I have limit as n goes to infinity. And I'm going to distribute a few things. I'm going to distribute this inside. And maybe also expand this as much as I can, just to see what the limit is going to be. So I'm going to be careful, though, to make sure we don't make a mistake. If I make a mistake, let me know. So I have 3 times 3 is 9, n plus 1 over n, plus For the second term, there's going to be 9 over 2. Then I have n squared in the denominator because one factor of n is left and one from the front. Then I have 2n plus n plus 2n is 3n plus 1. You may take more steps than me when you do this. Now, when you do this further, because you have limit as n goes to infinity, remember how we do those limits. You can look at the, so this was 9 multiplying the whole thing. I need to actually do this. 9 and then it multiplies n plus 1. Just if you look at just this part, that goes to 1 because you look at the highest power is same. It's n over n. For this one, again, I can just look at this part. The highest power is n squared. Oops, this should be squared, n squared, my mistake. 9i squared over n. That's these last terms multiplied together. Do you see that now? Like when I do the brackets, the whole bracket squared needs to be expanded as 2 brackets multiplied together. And you're doing FOIL first, outer, inner, and last. Okay, so this one again, you can see how just that part goes to 2 because it's the coefficient in front of n, but you have 9 over 2 times 2. But what I circled is going to be 2. So that ends up being 9 times 1 plus 9 over 2 times 2, which is 9 plus 9 is 18. That's our final answer. Okay, so it's just a matter of evaluating limits, and you should know how to do limits. Okay, when it's approaching infinity, you can look what's the highest power, the coefficients. If it's the same power, coefficients in front of it is what it's going to approach. And I just kept the constant out just to keep it simpler. Okay, so I'll give you like a 5-minute break. So we'll resume at, well, kind of 6 minutes at 3:10. Okay.
$137.92.
I look at you, you know, I see a young man who cheated online in chess when he was younger. And doing it at 13 years old and even 16 years old, 16 is worse. And also, if you did it in prize money events, is bad. But I don't have, and like you said, all I have is the chess.com report. And if you're telling me it never happened, it never happened. But I think what's your undoing, whether it's justified or not, given the way you were treated the last couple of years, is the way you act. Like, you show up here and accuse me of being a media, you know, puppeteer.
I speak the truth. And that's
Right,
something,
but
you know, it's very dangerous in today's world to do that.
I totally get it, man. Totally get
Well,
it.
maybe you might, that's your perspective, but I'm sure the people who watch this will understand and will appreciate my bravery for speaking the truth.
I think the way, first of all, I've commended the way you behave, because I think most people in chess are completely by the book. They're not a good interview. They say all the same things all the time, and they probably will not help the sport grow. At the same time, you are kind of mean. Like, you are mean to me.
Well, I should be, yes.
Yeah, okay, yeah, but you recently were in my.
Hurts,
I understand, but you were in my, you know, you were in one of my live streams recently and said we have no problems.
That wasn't a message. That was sort of trolling you. You know?
Oh, okay. But how do I know this whole thing wasn't trolling?
No, this is simply a moment where
Anyway,
it's time to face the music.
Okay, I get it. I don't hear any music at the moment, but
So this is the area. Let's begin. So let's say if we have the graph y equals x squared, and let's graph it. So it looks something like this. We're just going to focus on the right side of this graph. Now, let's determine the area under the curve from 0 to 8. Let's see if we can estimate it using the midpoint rule. And we're going to break it into 4 subintervals. To calculate the length of each subinterval, you can use this formula. Delta x is b minus a divided by n. So we want to find the area over the closed interval from 0 to 8. So a is 0, b is 8. So 8 minus 0 divided by 4 is 2. So the length of each subinterval is 2. So that's delta x. By the way, before watching this video, I recommend watching my other video on Riemann sums, left endpoints and right endpoints, and you could find it in my new calculus. Now let's say if we have the graph of y equals x squared. Now let's focus on the right side of the graph. How can we calculate the area under the curve a video playlist, or you could search it in YouTube. So let's continue. From, let's say, 0 to 8. So how can we determine the area of the shaded region? Now, one simple way in which we could do so is by using rectangles. So let's use rectangles. Let's actually use 4 rectangles to approximate the area. And there's 2 ways you can do so. You could use a lower sum, in this case, which will be the left endpoints, or an upper sum, which would represent the right endpoints for an increase in function. Now what we're going to do is we're going to draw 4 rectangles using the midpoint rule. And you need to draw the rectangles starting from the midpoint of 0 and 2, which is here, and the midpoint of 2 and 4, which is 3, the midpoint of 4 and 6, that's 5, and the midpoint of 6 and 8, that's 7. So we're going to draw a rectangle where the line intersects that point. So a portion of the rectangle will be outside of the curve, and a portion of it will be inside or within the curve. So the midpoint rule, it calculates the area of those 4 rectangles, and it approximates the area under the curve from 0 to 8. Now, as you can see, there's some parts that has not been accounted for in white, and also there's some parts that shouldn't be accounted for also in white. And so the midpoint rule is a good approximation for estimating the area under the curve compared to the area using the left endpoints and the right endpoints. To calculate the area of each rectangle, we need to multiply the width of the rectangle, which is delta x, times the height of each rectangle, which is the y value that corresponds to a certain x value, or you could say that's basically f of x. At some sample point x, or x sub I. The area is going to be the width, which is the same for each rectangle, times the height of all the rectangles. So we're going to sum up the individual heights for each rectangle, starting from 1 to some value n. Now n is 4 in this example because it's 4 rectangles. What we need to do is create a number line. So going from A to B, 0 to 8, and there's 4 subintervals. This is the first subinterval, this is the second one, the third, and the fourth one. Now, if you were to calculate the area using the left endpoints, we need to choose 4 out of the 5 points listed. So that would be 0 to 4, and 6. For an increasing function, that would be an under approximation or a lower sum. If we were to calculate the area using the right endpoints, we would use 2, 4, 6, and 8. So this would lead to an over approximation or an upper sum for this example. But using the midpoint over, use 2, 4, 6, and 8. So this would lead to an over approximation or an upper sum for this example. But using the midpoint rule, we're going to get the points in the middle of each subinterval. So that's going to be at 1, 3, 5, and 7. 5, and 7. Going to be at 1 times 1. So it's the midpoint of each subinterval. Now we know that delta x is 2. And f of 1, we know that f of x is x squared for this example. So this is going to be 1 squared, which is 1. 3 squared is 9. 5 squared is 25. And this is supposed to be a 7. I don't know why I put a 6 here. 7 squared is 49. So first, let's add 1 and 49. 1 plus 49, that's going to be 50. And then 9 plus 25 is 34. 50 plus 34 is 84. And 2 times 84 is 168. So this is the area using the midpoint rule. Let's see how close we are. Square d cube over 3. So that's the actual area under the curve. Now let's try another example. Let's say we have the function x to the third. Now let's try another example. Let's say we have the function x to the third. And I want you to estimate the area under the curve over the closed interval 0 to 10. And choose five rectangles. You can break down that interval into and choose five rectangles. You can break down that interval into five sub integrals. So go ahead and use the midpoint rule first, and then calculate the definite integral from 0 to 10 to see if the answers are close to each other. Times f of 1 nation 129. The act of the 4 is going to be by 5 of the integral.